Hey everybody, welcome to the display case build. So what I'd like to do is take a real deep dive into all the steps and processes related to making a complicated piece of furniture, frame and panel display case for a little food cooler to go in. This is something that I feel like until you see the whole process from end to end, it's hard to kind of wrap your head around how to build a large piece of furniture. So I'm gonna go into quite a bit of detail here, and I hope you enjoy. So here's a fly through of how the whole frame goes together. All the frame members get slotted into their mortises, then the panels are assembled into their frames, and those are attached, and then finally the shelves are installed, the top, and then the actual display case that's going inside it itself. So after I built a CAD model, I used my software to output all the parts that I needed, the quantities and the total length and the thickness and the width, and there's a base length, and then I added a little bit of extra to it and used that to calculate the rough length, which is what's in this column, and that's what we're going to be cutting first, and just left some squares here for, checking off stuff and details. Armed with a list of all the rough lengths that I needed, I hauled a bunch of lumber from the storage area and started figuring out which pieces were going to go where. And this is just cutting to a rough length, so I left about 2 inches on each end, or 100 millimeters on the actual length. And that's to do two things. It's to give myself a little bit of wiggle room, and also because the joiner I was using at the time was really susceptible to snipe, I wanted to ensure that I wasn't going to have a big sniped end on a piece of these boards because I cut them too short. So this was just a matter of taking each of the pieces, ripping them down to rough width and length. All these are just bandsaw cuts. There's no need to be too precise, and I'm leaving quite a bit of overage on all this. There's going to be a little more waste this way, but it's going to ensure that each piece of wood is exactly has the right grain and the right, and also that each piece is dimensionally straight and true. Here's all the components cut to rough width, thickness, and length, and I labeled each of them per the plans there. And then now I'm going to have to resaw some of these pieces down the middle, but first I'm going to joint each of the sides so that I have a flat reference surface. And lots of joining on the joiner, so I want to have a reference surface and edge for the resaw. Now, resawing wood can be a little tricky. The bandsaw I'm using is a Hitachi Resaw, which is excellent at doing this, but there's still a lot of effects that the tension in the wood can cause. So it's not the best idea to use a fence when you're doing this type of resawing. So what I'm doing here is I'm using a marking gauge to draw lines down the center of the wood as it sits. And an easy way to do that is to just get your marking gauge close to the center and then just do lines on each side. That way you're not going back and forth with getting it lined up. Plus you have the added advantage of more or less having a little road for the bandsaw blade to go down. And the reason we're doing this is because then we can just follow this line and not have to worry about a fence pushing the wood one way or another, because as you start to resaw the wood, the tension in the wood will cause the wood to either tighten up or spring apart, which could mess up your cut if you use a fence. In some cases here, I had to put a starter groove with a circular saw to get a nice resaw. Now all those boards that I just resawed go through the planer again to take them down to the final thickness, and we're going to plane both sides so that we have an even amount of tension removal, I guess you could say. If you plane down just one side, you start to remove some of the wood that's in tension and the board will cup, so you sort of want to balance that between both sides of the wood, but at the same time, you want to keep an eye on the grain because you basically made these booked match pieces by resawing them, and so when you fold them open, the grain is going to be really nice. So if you take too much off of each side or unequally, then that grain isn't going to line up and it's going to look weird when you make them into panels. After all the boards are planed to thickness, we're going to rejoint the edges, and I am sort of pushing down in a way very slightly that causes the center of these boards to be a little more jointed than the ends. And what that'll do is it'll allow us to have a slight gap in the middle of the panel. And when we glue them up, that gap will close. That way, if the ends start to open up, or there won't be any gaps in the panel. Here are all of the panel boards with a triangle to indicate the orientation of the boards. And on this one over here, you can see the small gap in the center. That little bit of black, and that's going to get closed up when we clamp everything together. Here I'm marking all the locations for the biscuits on the panels. So there's a lot of debate whether or not biscuits are necessary for panel glue-ups, and the internet seems to think that it's stronger to just use the edge-to-edge glue joint with a high-quality glue. However, one thing that biscuits do really help with is a nice lineup of thin stock that's tended to warp and whatnot, and I find that very helpful. You don't have to use a whole lot of cauls, so I'm just putting biscuits in these panels. And now it is time for the most stressful part of any woodworking project, the glue up. So we insert all the biscuits, put glue on all the edges, and clamp all the panels together tightly, and add a couple of cauls to keep everything straight. Here I'm joining down and planing all the parts for the large top shelf on this display case, which is going to have an interesting design with a mitered frame around a floating center panel. So I needed to prep all this stock and then do another glue up of the panel there. Alright, so while the panels were drying, I moved on to jointing all of the frame components. And I think this is probably one thing that I really came to enjoy about doing this type of woodwork while I was in Japan is I think I used to do a lot more jointing and planing and then using the table saw to rip components to final thickness, whereas that can open up tension in the wood and cause it to bow a little bit. So in this case, we bandsaw everything to rough size and then joint everything and plane it down so we have really true pieces to work with. Another thing to really pay attention to is the grain direction while you're doing the jointing and planing. And if you ensure that you plane in the correct direction and flip the board in the correct direction when you send it through the planer so that the blade is always engaging the grain in the right way, you'll have a lot less tear out and it'll be a lot cleaner for finishing work. You'll see at the end of the joiner those 4 black lines, and that is a reminder in which direction the grain should slope when I put the board through the planer to make sure there's not tear out. As far as the joining and planing process, so I start by jointing a flat face and a flat edge that's 90 degrees to that face, and I mark it. And then I use that mark to remind me that I'm going to be making the opposite face parallel and the opposite edge parallel. So I'll remove a bit of material off the opposite face, then flip the board end for end and take off a final cut on the original jointed face, which will remove some snipe, and the planer will clean up the rougher joiner marks. And then it's the same thing with the edge, because we're not using a table saw to make the edge parallel. We send the wood in to take it down to final width, basically. And it's the same thing. We take down the bulk of the material, then flip the board end for end to do a final clean pass on the originally jointed edge. And we can take the panels out of the glue-up jigs and start the pleasant process of scraping off any glue drips and then using a sander to unify the panels. And this is something where one of those wide belt sanders would be real nice, but doing it by hand is totally fine. So on the end of all the frame pieces, we have a little bit of snipe from the jointing process. So I set up a stop here on the sliding table saw so that I can push every frame piece against it, and I'll be able to take off a consistent 50 millimeters off of one side of each of the frame pieces. And so I work through all the frame pieces, cutting off that sniped edge, and then what we'll do after they're all cut on that side is we'll use a stop to set the correct, precise length of the frame pieces, and we'll cut the other side to length. So here I'm referencing the worksheet because the actual length of all these pieces now becomes really critical, because when we make our tenons, they're going to be referenced off the ends of the pieces, an exact distance. So if we don't have equal length parts where they need to be equal length, then we're going to have a wonky case. So I make sure that they're really precise. I'm measuring with this rigid ruler each time and shaving off a little bit. And finally, when I get the piece the right length, I can use a stop to set the multiple. You can use a stop to repeat for multiple parts. Now that we have all the pieces cut to their exact length, we're setting the saw to a height for the shoulder of the tenons. And we design the tenons in such a way that we can leave this shoulder height consistent around the whole part. And you're basically just rotating the piece and then flipping it end for end and doing it on the other side. So you make a shoulder cut all around the part, and you don't have to change the blade height each time. But it's very important that you get these tenons the right length, because the length between the tenons is the exposed part in the frame. And so if there's any inconsistencies, or if there's other parts that depend on that length, the frame is going to be kind of out of square. But the setup is the hard part, and once you get the tenon the right length, you can just crush through, a whole bunch of frame pieces. A very important thing when doing this is that you have either a single point or a very square end stop, because if you have an end stop that has any kind of tilt, or basically if the end stop causes the board to change its effective length relative to the blade when you're holding it upright or holding it long ways, then you're going to get shoulder cuts that don't line up and match all the way around the part, and it's going to leave gaps and look like dog shit. In preparation for the layout, I marked the interior corners of all the verticals for the frame and labeled the bottoms accordingly. And I arranged them so that there was a slight warp pointing in. The crown was internal to the case, and that will help tighten up the case as any movement happens. At this point, we've milled all of our frame pieces to the correct dimension, cut them to the exact length, and then cut the tenon shoulders in all the pieces. And next we're going to be doing the layout for all the mortises that are going to get cut. It's really important that this is done very accurately, because the position of the mortises will determine how square and tight all the joinery is. This process is repeated through all the different frame members. Basically, we create a reference line at one end, if that end's going to get cut, and find the centers of all of our mortises along the length of the piece. And we can wrap those center lines around the piece if necessary. And then off those center lines, we size the height of the mortise. And then we use a marking gauge to establish the width, of the thickness of the mortise. These are double mortises, so we have basically two holes next to each other in each location. Here's the layout finish on all the vertical members. We left these members longer than their finished dimensions because we don't want the mortises to blow out at the bottoms and tops of these pieces. Cold morning here at the shop, and we are going to get started on mortising out all the mortises for this cabinet. We got all the pieces sized, cut to length, and all the cheeks cut around the double tenons. And once we get the mortises cut, then we'll be able to cut the shoulders of all the tenons, ensuring that they're a slip fit on the sides and nice and tight on the top. These are a millimeter undersized for the tenons, so a half millimeter on each side basically, which is going to make for a really tight, solid case. A good sharp plunge chisel mortiser with an accurate bed and a nice big hand wheel is very nice to have when you are chopping tons of mortises. So I set all the heights. I try to do these in a batch. I've set the height of a specific mortise on the machine, and then chew away at all the material to make the mortise cut. In some cases, you could use end stops to position your chisel on the wood, but because in many cases we have to move long pieces through here, sometimes it's just easier to do all the layout and then cut to the line. In almost all the cases, we plunge on one end and then the other end of each mortise, then clear out the waste in between those ends, and then we kind of bounce the chisel and slide the thing back and forth so that the bottom of the drill bit kind of cleans out the bottom of the mortise. And we size these mortises a little bit deeper than the tenon so that we don't have to worry about waste causing tenonitis, which is where the tenon doesn't fit in the hole. The reason we start on one end and then go to the other end of the mortise is because if there's an unequal amount of wood, like let's say you chop 4 holes in a row, and then the last hole is a half size, you could have the wood pressure move the chisel, and it will make for an inaccurate mortise. With the mortises cut, we can start cutting the cheeks for the tenons. And I love this machine for that because you just slide the piece in there and the blade eats away at the wood. And because of the curvature of the blade, it gives you a slight undercut and leaves a small piece of material that can compress into the joint for a nice tight fit. It looks really dangerous, but as long as you keep your hands behind that sort of fence line there, that table, you don't have anything to worry about. And I almost want to build one of these machines for myself because the adjustment on this one is just very tricky. But once you get it set, you can crush through just tons and tons of pieces. I like it so much better than a stand-up tenoning jig for a table saw. But getting that table set to the right height so that the center of the wood is at the center of the blade rotation point, that would benefit from an accurate scale or some sort of lead screw or something. Now all the pieces have had their tenons and mortises cut, and the last step in preparing them all is to cut the grooves down the center for the panels to fit in. So I really don't want to mess these pieces up because a lot of work has gone into them and a lot of setups. So it would take way longer to remake one. So I'm marking a oh shit line where all the grooves are going to go. And then I set up a jig on these sawhorses to hold the pieces really tight because we don't want the groover to slide in one direction or the other and make a mess. To cut these grooves, I make sure that I have the groover pretty much dead centered on the edge of the wood and a little bit smaller than the final size, so I can run the cut on both sides. And that'll ensure that the groove is the right thickness and also that it's exactly centered on the piece. Finally, a little chisel work. I'm using these beautiful Masashige bench chisels to chamfer all the tenons and then clean out the ends of the grooves where the groover's curved blade left a little bit of a radiused end. So I clean that up and make sure there's nothing that's going to catch on the panels. Now that all our frame parts are basically done, we can move on to cutting all the panels to the right dimension on our sliding table saw. And I'm doing the same here with the large top panel. That's going to get a little more processing before it's assembled. So cut that to the right length and width. And then the next thing I'm doing is cutting basically shoulder cuts for very long tenons. This panel is going to float inside a frame, and so I wanted to get accurate cuts for the tongues, basically, that it's going to fit in that frame. And here you see me using a groover to finish cleaning up the tongues on each side of this floating piece. I cut those shoulders in instead of just using the groover to begin with because I really want to make sure that those edges were not blown out. And by cutting with the sliding table saw, it made for a much cleaner edge. And finally, a little hand planing to chamfer the ends and clean up the corners and basically get this piece ready to go. To prepare the frame pieces, I started by putting a pretty substantial groove in each one. And that's much deeper than the thickness of the tongue, and that's to account for the panel to expand and contract during different temperature changes. In some cases, I'm using clamps here to make sure the piece is dead straight, so the groove is also straight. Next is laying out the miters for each of these frame pieces, and also doing a test of the fit on the central panel itself. And we want to make sure that these lengths are really accurate in order to ensure that there's a tight fit around the whole frame. Alright, I laid out for the miters on this top, and then I also added 1 centimeter increments to the left and right, and that'll give me test cuts so I can dial in the angle. Here we got a miter jig on the sliding table saw crosscut sled, and this was set up pretty precisely before. We'll see if it moved any, but I'll cut each of the test cut lines and then do an assembly and see what the gaps are like, so I ensure that when I do the final cuts everything will line up just right. This is our first test. You can see it meets tight in the inside corner, but there's a hairline on the outside corner. So we'll make a slight adjustment to our sled and then cut the next test cut line. So I'll adjust the poor man's miter guide here by just loosening the screws and moving the fence, and then I'll take another cut, and hopefully this will let us dial in that miter. And this is on the final line that's going to determine the size of the frame. Here I'll lay out all the frame pieces on the floor here with this frame clamp, and tighten them all up and ensure that there's going to be a nice gap-free fit when they're glued together. And also I'm marking the location for the biscuits that will hold these together. This time we close up that outside gap, and now we just got to run all the cuts again on the main line and hope that they all go well. Now here is a case where biscuits are super useful because gluing end grain to end grain is just not very strong with wood, and even though it's angled, it's still pretty weak. So I'm gonna add 2 biscuits on each miter cut that we can use to glue everything together. Got this jig set up on the panel saw, sliding table saw, and the blade is tilted, and this is a real rigid fence, and that'll allow us to make these raised panels. So the panel will sit in here and clamp flat, and then it'll ride through the blade. A little horrifying. Let's get one set up. I will say this was a little horrifying to cut, and also there was slight warpage in the panels, so it was really tricky to get them dead flat. I would prefer to use a raised panel shaper bit, but got to make do with what we have. Now that finished the bulk of the machine work, and next I was gonna plane down any of these burn marks on the raised panels and clean up them, sand those a little bit, and move on to final finishing of all the pieces. So as with every project, it's a continual education in plane tuning and setup. And I must have sharpened this plane several times in order to get a decent finish on this really hard white oak. But when you get a nice cut on white oak, it is just gorgeous. You have these beautiful ray flecks and just a nice shine, and it's really pleasing. Normally when we make a mitered frame, we do the finish planing before the miter cuts because of this exact problem here, where it's very hard to plane something that has an angled end. But because of all the adjustments to the miters and the biscuits and all that stuff, I really didn't want to damage the surface finish, so I built this little jig to capture the angled end so I could plane down the frame pieces for the top. Then to finish the top surface, I cross-grain planed it to flatten everything out, and did a rough planing, and then finished it with a light sanding so that it looked clean and smooth. All the pieces were finally finished, and after finished sanding on the panels, I moved on to coating everything with a natural oil, sort of a gold oil finish, and then things started to get really fine because it all started to pop and the rays started to reflect off the sun, and it was getting exciting at this point. Finally, we could do the assembly. So I started with the top panel, and this was the trickiest one because I had to get 4 pieces lined up in a fairly tight groove and then put biscuits in it and make sure those biscuits seated really well in fairly tight white oak biscuit holes, and then clamp everything together. And it was harrowing to say the least, but it all came out nicely. Next up was the front panel, which had 2 raised panels and a little central stile there. So I started by attaching the central stile and then sliding in the 2 panels. And now this is going to get captured between the main uprights, so this is more or less a sub-assembly. Next I moved on to the large side panel. The clearances of this room were such that we only had panels on one side of this case, and that was also to allow the little refrigerator display case thing to slide in. So this was a tricky one because the panels were a tiny bit oversized, so I had to trim them to get them to fit just right in the frame. But ultimately, it was not a problem. I just had to do a little bit of adjustment. And I kind of wish I had checked this before I had glue in the mortises, but that's a lesson learned. So, double check your parts before you do final assembly. I used the completed side panel to start attaching all the rails for the case. I made sure the tenons fit just right. It was nice and tight, and then we put glue in the holes and attached all the rails. Then there was the sub-assembly for the front panels that went in. And then I had to make sure the panel lined up in its groove. And then finally we would attach the top frame that completes the case frame. And that's tricky to get everything to line up, and then you got to clamp it really tight on each of the rail members to ensure that the joints seat nicely. After the frame was together, it was time to install the shelves. So these were made a little differently. We basically made little supports that then screwed into the interior of the frame, and then a plywood shelf sat down in on top of it. And this was to ease the construction labor, but also to allow for flexibility, because the refrigerator had these vent holes and it needed to be able to kind of be sized after the fact. It was definitely easier to drop in some plywood shelves than it would have been to integrate that into the case construction. So here I'm cutting those shelves to fit and screwing in the little supports and stuff like that. After the shelves were installed, I prepared the bottom shelf, which had casters on it, and these casters floated just a hair below the bottom of the cabinet so that it looked like it was sitting on the floor, but actually it was riding on casters, and that's so that the clients could pull the piece out and maintain the refrigerator inside. And then I had to cut the lengths of the uprights to final dimension. We left those long, remember? And then I could put the top on and put little brackets to hold it down from the bottom, and this is complete. Here's a couple of shots of the finished product. It was really enjoyable to be able to take a concept from design and part spec and lumber selection and part rough cutting, milling, joinery, planing, finishing, assembly, the whole process end to end. It really taught me, like, this is how a piece of furniture goes together. Here are the gotchas, here are the things you got to worry about. So I hope that everybody found this video valuable, and it may seem complicated to build a large piece of furniture, but you really just got to break it down into different processes and then do one step at a time. Pay attention to layout, pay attention to the details, and you'll get a nice looking piece. So thank you for watching, and I'll see you next time. Thanks everybody for watching. If you found this content helpful, please consider supporting Never Stop Building. The easiest way to do that is to simply hit that red subscribe button and click the bell to get notified of new videos and content that I release. If you really want to be my best buddy, become a Patreon subscriber, where you can get plans to all these projects, exclusive content, and much more. So check the description below for a link to that. And as always, never stop building.